Good morning, everyone. For today's discussion, I'm going to discuss the test of significant difference. Test of significant difference is commonly known as, sa Bisaya pa, is to test kung naabay kalainan ang duha. Sometimes, we just see the mean kung naa siya'y difference, pero when we use the test of significant difference, we can infer na naadjud siya'y kalainan, their variance. So usually, if we will conduct a research and the common objectives, the third objectives will say test of significant difference. Now, for the test of significant difference, most of the non-statistician will have the hard time to comprehend about that. But that is just simple. When you have an objective that says test of significant difference, you only have to find out whether are you going to use the parametric test or non-parametric test. For the parametric test, if you are going to test the significant difference of two groups, what are the variables that have two groups? For example, gender, we have the female and male. They should be mutually exclusive from each other, so no overlapping. So that is two groups. How about with the three groups? This one of the example for the test of significant difference for three groups are the civil status. We have the married, the single, annulled, divorce. So they're also mutually exclusive. So when we say civil status, their status in the civil registry. So for the parametric test, we have the t-test for two groups, and we have the ANOVA for three groups or more. So usually, for non-statistician, they are just going to do the t-test and then the ANOVA, but they do not know that if your data will not arrive with if your data will not achieve the assumption of parametric test, you need to do the non-parametric test, which is the Mann-Whitney and the Kruskal-Wallis for three groups. So we need to check the data that we are going to use this one today for today's discussion. So here is the data of my student, and we are using it now. So here, this is the name of the respondent. Your data should look like this so that it would be easy for us to analyze in any statistical software. But when you run this one, you need to create another sheet. Always remember that you need to create another sheet. Why? Because sometimes when you do coding, it's very hard for us to analyze if we have some mistake, we can compare it to the original one. So always remember that when you data analyze, you need to make sure that only the raw data is available in your sheet, which means there is no other summarize that's overlapping with your data. So this one is your data should be per respondent, and make sure that the first row is the column heading, because if you add another row and the column heading is in the second row, the only column heading that the Jamovi or any statistical software that you will use, they will read only the first column, the first row. So make sure that once you run it to a Jamovi application, the column heading should be in the first row. So your data should look like this. Now here, we need to compare it to our discussion earlier that for two groups, for significant difference, you need to use it with the gender, because with gender, we only have female and male. So we can use the t-test here, but if the assumption is not being met, you need to do the Mann-Whitney test. So here um, we need to code first the data so that when we run this one to our statistical software, it would be very easy for us to run it to statistical software. So for example, we are going to group the age. So we will put age group. For the age group, you can put young, and then you can have 1, which means that is less than 20. So any less than 20, we will code it to 1. Okay, so you need to code it to 1. And then for the average age, which is supposed to be 20, we will code it with 2. This is for the, and here we have to code the 21 and 23 as 3. So therefore, for the age group, we have 3 groups, which means we can now use this one for ANOVA test. So again, this one you need to do it with the 2 groups, the gender, and also for the age group, that is 3 groups, you need to do it with ANOVA. So if we look at here, the age has already 3 groups, so we can run the ANOVA. Again, for the t-test, you need to have 2 groups. An example of 2 groups is just the gender. We have the female and male. And for the ANOVA, you need to have 3 groups. And we have grouped the age here. We have 1, 2, 3, and this is the 3 groups. Now, the t-test and the ANOVA should meet the assumption of parametric test. Now, if the assumption is not being met, you need to do the non-parametric test, which is the Mann-Whitney and Kruskal-Wallis. We are going now to run this test in the Jamovi application. You need to remember this one, that once you close this Excel, you need to be in the sheet of data analysis, the sheet, because if you stop by here, once you import this one, the Jamovi app will read your previous sheet that you open. So here uh, you need to stop by here with the sheet that you need to analyze. So you need to close this one because you are going to run it in the Jamovi application. So I actually have 4 statistical software here, the SPSS, the R, the Jamovi, and then this data. So for our school, the available software that we have in our office is the Jamovi application. It is available in our common files. So once you install the Jamovi application, it will easy for you to run the application by just clicking the software icon. So for you to easy to locate it, just pin it in your taskbar. So this is the Jamovi application. Now, you are starting fresh. Therefore, there is no data here in your sheet. So you click this horizontal line, and then you will have to import the data. And in importing, you just click the word import in this PC, and you need to click the browse, and you need to locate the folder. So in my case, I save it in the desktop. I have the shortcut here and the test of significant difference, and I'm using the data of my student. Then you click it. Once you click it, the Jamovi application will import your data. So here, but the ABC, I think this is a default. So you can just delete this one by highlighting and right clicking it and delete variables. So once you delete it, you need to make sure that you have saved this project by clicking the horizontal line, horizontal line, and then you click the save, and you need to locate You need to put it in here, test of significant difference. Sometimes the the your teacher will have different objectives, and commonly used for the objective are three. Sometimes they have to create the demographic characteristic. So in analyzing, you need to create two files. One file is for statistical output, because if you are a statistician or if you are a researcher, um, it is in the appendices. We need to find out if your data, if you have really run it to the statistical software. So you need to create two output, two Word file. The statistical output are those output you will be getting from the Jamovi application. So here, you also name this one statistical output. Statistical output. So statistical output, after running the statistical output, if you can see it, we have the title of our project, test of significant difference. Now here, you have this analyze taskbar, you have the exploration. The exploration is the descriptive statistics. Now, since your data is in ordinal or is in scale data, you just need to put the variables here. And this is for my student, Sinahon. And for the earth science, there is no data for the earth science. So this is the descriptive statistics. You need the mean, median, and standard deviation minimum. You can also choose here what statistics you want to have. But for my class, I require them to only have the mean, median, the standard deviation, the minimum, and maximum. Then afterwards, you can also, after getting the descriptive statistics, you need to do the right click first, and then you copy. And this output is you need to put here in your statistical output. This is for my student because they need to submit this one proving that they have run the output in a statistical software. So just control C and control V. After getting the descriptive statistics, we can now go to t-tests. First is we will have the independent sample t-test. So this is the test of significant difference. So we have here, okay, for the t-test, we need the grouping variable. The grouping variable here is the gender because we only have two groups for the gender, and we can run all the dependent variables because the gender can stand alone. That's why it is independent. And the grade is dependent, maybe dependent to the gender. But let's see if here. So that's it. So we can see here that the p-value is not less than 0.05. So how do we analyze this one? First is you just copy this one first. Let me see, it's not working. This one is the t-test, so you need to put it in the statistical software here. So that one, that is for the t-test. Now, to see, since there is no significant difference for the for the gender because the p-value here is the analysis for that. If the p-value is less than 0.05, that is significant. Right? Okay, so when the p-value is less than 0.05, you need to look at here. If some p-value is less than 0.05, it means that there is a significant between the two groups. Remember our two groups here, we have the gender. So you need to name here gender. So here, since there is no less than 0.05, there is no significant difference. So Gen Math, regardless of the gender, they have the same grade. Art app, regardless of the gender, they have the same grade. Genetics lab, they have the same like and whatsoever. Because there is no p-value that less than 0.05. If there is a p-value that is 0.05, so um you need to look at that there is a significant difference between the two. Now, sometimes in real world and most commonly used, we do not run the assumption and just do the t-test. So in here, for the parametric test, since we are using the independent, you need to um, check the assumption first. So we have here the homogeneity test, the normality, and we can see also the QQ plot. Now for the assumption check, um, this is the tricky part because the p-value here for the assumption of normality test is it should be greater than 0.05. When the p-value is greater than 0.05, therefore, you can run the t-test. So here, this is the assumption, right? So when you check the normality test, you may add here, this one is non-para. Okay, so here is you need to normality is given, the data is normally distributed if the p-value is greater than 0.05. So we can see here, and this is corresponds to parametric test. So the only that is less than 0.05 is this one, non-para. You need to do it with non-para. Also here, non-para. Okay. So sometimes if your teacher is not really concerned with the assumption, t-test is enough. Okay? But if they are really into the assumption check, they need to look at first the if we are going to use the parametric test or non-para. Since the p-value here is less than 0.05, so therefore we need to use the non-parametric. So here, we can conclude that here we need to use Mann-Whitney. Why? Because it did not pass. It should be run through the non-parametric test. Also, the rhythm and activities. Okay, and you have the, because the three of these did not pass the assumption, which is normality test. So therefore, the GenMat and the rhythmic and NSTP, we need to run it using the non-parametric test, which is the Mann-Whitney. So we have here the Mann-Whitney U test. This is the graph. for the test of assumption. So for my student, you do not need that one. And then you need to click the Mann-Whitney U test. But you need to remember that for Mann-Whitney U test, the only the only subject that you need to run is only three. We have the GenMat, the rhythmic activities, and then the NSTP. NSTP. So anything that is not included, the subject that it is that need to use parametric, you do not need to run that one. You only need to run um, the Mann-Whitney. So we have here this one. So this one is the Mann-Whitney U test. It is still called independent sample t-test, but right now we are using the Mann-Whitney U test. Since this variable, the GenMat rhythmic activities and STP is not normally distributed. Now, how do we know if the data is normally distributed? You need to just do this one. If the data is normal, the p-value is 0.05 for the test of normality. And we can see here that GenMat, rhythmic activities, and NSTP is not a normal. The data is not normally distributed. So since GenMat, rhythmic activities, and NSTP are not normally distributed, they need to use the Mann-Whitney U test. So we can see here that Mann-Whitney U test is used in GenMat, rhythmic activities, and NSTP. So that is the test of significant difference for the um, for the test of significant difference of two groups. Now we have here to put it in the results and discussion. Results and discussion. So for my student, they need to put it here, results and discussion. And they have four objectives, but for the test of significant difference, I guess it is in their fourth objective, so they need to put fourth test of significant difference. Now for the test of significant difference, they need to have to make a table, and then their table should look like this. They have 5 and they have 10 number of rows. We have the variables, which is the gender. Since there is no, you can also have the p-value because we are only concerned with the p-value. Here, the statistics, the DF, we are not really concerned with that one. We are just concerned with the p-value. Then p-value and then test use. This is for my students, okay? And here is you need to put the significance. And then we have the decision of HO. Now for the variables, you just need to copy this one. Copy it here. Paste it here. Okay. And then the p-value, if it is Mann-Whitney, put here Mann-Whitney. Okay, so those you run for Mann-Whitney U test, you need to copy it here because this is the p-value for the Mann-Whitney. Okay, and for the t-test, you need to copy it here. Everything that you have, copy here. Also here, the facilitating learning. And the test used here is the t-test. Now, as a teacher, I already know that those who use Mann-Whitney U-test was not able to pass the test of assumption for normality of the data. So here for the significance, we have the legend. Significance, eh, significant if the p-value is less than 0.05. But since there is no p-value that is not 0.05, so therefore not significant. And then you need to put the decision of the HO. Since we were not able to uh, prove that there is significant difference between the gender, so you need to put fail to reject. Fail to reject the HO since our data is not enough. It's not sufficient to prove that there is a significant difference between the gender. So, for example, if there is a significant difference, this is just for example, okay? For example, if the GenMat, we have the p-value that is 0.003 or 0.03, that is less than 0.05, right? So you put here significant. And you need to reject the HO. Now, if there is a significant difference between the two gender here is the female and male, right? So you need to look at the mean of the male and female. For example, for GenMat, the mean is, this is just for example, okay? The mean of their score is, for the female is 2.12 and then for the male is 1.8. Therefore, and then there is a significant difference between the two, we can conclude that in terms of GenMat, the male are smarter for their grades. So you need to adhere mean. But since based on the data of my student, there is no significance between the two because the p-value is greater than, so therefore you do not need to compare since they, or you can also put here, you can also put the male and female and you see if, what if we add more, okay? But in this case, for the data, there is no significant difference. So we have here, to, we need to do it this part. Or you can put the female and then male so that you will be able to see and then if how much do they differ from each other. The Mann-Whitney here is 2.263. So after that, you can see or you can run another test here. But then again, this one is not fail. This one is fail to reject. So, sorry for that. The male and female, you can have the exploration, and then descriptive statistics, and then you need to split it by gender. And you go for all the subjects. So here, it is split by gender. We have the female and the male. So you can add here. So for the GenMat, you can put the GenMat here. This is the mean of the GenMat for the female. So you just copy and paste it here. Also this one. Okay. Oh, so the p-value is missing for the GenMat. So that is 0.263. So how do you discuss this one? You can discuss. You need to name the table. You need to count the table and then you put table number 2. Test of significant difference of the grades of Chuchu. What grades are that? You continue that one. So how do you discuss this one? The table above shows the test of significant difference by gender. Based on the table, at 5% level of significance, this one is 5% level. The table above shows the test of significance by gender. Based on the table at 5-point level of significance, there is no enough evidence to reject the null hypothesis that gender vary when it comes to their grade. This means that regardless of the gender, the grade of the students, the grades, okay, so you just need to discuss further this table. I will be showing to you later the further discussion, because if I'm going to discuss everything, it is as if I am spoon feeding my student. Okay, here we are done with the t-test. Let's go now to test of ANOVA. We have here the one-way ANOVA. Okay, for the one-way ANOVA, you only have the age group here as a grouping, and you can have all the grade in the dependent variables. So here you need to also test the homogeneity test. So we can see here that p-value, what if we assume equal features? Here, we can see that everything is not significant because the p-value is not greater than 0.05. So you need to put that in here. ANOVA, paste it here. We have the p-value. Remember the rejection rule. You need to remember that we need to reject the null hypothesis if the p-value is less than 0.05. So if we look at here, if you look at the p-value, there is no significant difference between the age group. So therefore, the analysis here is regardless of age of the students, they have the same grade. So even if you're above 20 or less than 20 or your age is 20, based on the data gathered, they have the same grade. So in unison. But the question is, have they met the assumption of parametric and non-parametric? So you need to test the homogeneity and then the normality of the test. So here we have the normality test and the homogeneity of leaving test. So here the only who passed the assumption is the everything except the NSTP and then the GenMat. So therefore, since they were not able to pass the assumption test, we'll copy this one here. Assumption test, normality test, here. Then you you need to test it using the Kruskal-Wallis. Kruskal-Wallis is still a one-way ANOVA, but it is non-parametric if your data was not able to pass. So you need to do the non-parametric test. Okay, so we have pairwise comparison. So you use the pairwise if the result of your test shows that there is significant difference between the group. So kung magkalain-lain ang age, you need to do the pairwise comparison. So we have here, this one you need to use the non-para because the p-value here is greater than, that is for the assumption. So since this one is less than 0.05, so this one should use the non-para. Wait, we need to put here non-para. Non-para. Also this one, non-para. So you need to run the NSTP and the GenMat using the Kruskal-Wallis test. So the grouping variable is still the age group. And you also have the NSTP to check and also the GenMat. But usually they have the same answer. Okay, so still the p-value is not less than 5.05. So therefore, there is no significant difference. This means that even though you are less than or greater than 20 years old, you have the same grade. Okay? So, you can make the groupings and change this one. And here is still the same because this part is still the same, so we do not need to put that one. So you need to put here less than 20 years old. Here is 20 years old and here is above 20. So you can put the mean here. But since they do not differ from each other, no need to put it here. P-value of, oops, this one is for the GenMat and this one is for the NSTP. Okay, and then So this one is Manwitney because it was not able to pass the test of significant difference here. The rest, you need to do it with t-test. I mean, with ANOVA. Oh no, this is not Manwitney. This is Kraskell-Wallis. So this one is the ANOVA. Also, this one is ANOVA. So since we are using the ANOVA here, you need to copy this one, the one-way ANOVA, but not for the GenMat. And you need to do the Welch. So you need to copy the Welch, for example, this one, and paste it in the art app. Okay, you paste everything from the one-way ANOVA here. I will not be doing it for you because it is spoon feeding. So after, if you want to see the distribution by age, you just go to the expiration and then descriptive statistics, and then you put the split by age group, and then the variables, which is the here. Okay, we have the 1, 2, 3. You remember with our data, we group it by 1 is equal to less than 20 years old, the 19 years old, and the 2 is for the 20 years old. So here, you are just going to use the mean. So you do not highlight that, but just remember that you're going to paste this one here. Let's do the GenMat. 20 years old, 21, and then this one. You only use the mean, okay? Because this is continuous. So just use the mean. So we can see their average grade. Now, afterwards is you still need to discuss that one. We will go to the discussion, a sample discussion. Okay, so this is an example of the explanation when you do descriptive statistics. This is the second objectives of my student. So you need to do like this in terms of median, standard deviation range, minimum and maximum. But here it is the overall academic performance because they're using the GPA here. And you need to discuss it per subject. Okay, and you use this one. And you do not have like this, so do not put this one. Just only the median, standard deviation range, and minimum and maximum, and you need to follow how it is discussed like this. Okay, and an example of test of significant difference, like this one, use of AR by generation. In here, they have 3 groups. So I use here Kraskell-Wallis because their data is in ordinal. So how you discuss, you need to do it here like this. This is how you discuss this one. And you need to put it in a results and discussion. So the discussion here is there is no significant difference. On the average shows that there is no effect on the use of AR because of this one. The p-value is not less than 0.05. 0.527 is not less than 0.05. So that's why it is not significantly different. So that's all for your results and discussion and for your statistical output. And you need to install the Jamovi app. Thank you. And once again, good day.